All right, we got 2017 number 2 here because I can't count. The manager of a local fast food restaurant is concerned about customers who ask for a water cup when placing an order, but fill the cup with soft drink instead of water. The manager selected a random sample of 80 customers who asked for a water cup when placing an order, and found that 23 of those customers filled the cup with a soft drink from the beverage fountain. A. Construct and interpret a 95% confidence interval for the proportion of all customers who, having asked for a water cup when placing an order, will fill the cup with a soft drink from the beverage fountain. Alright, we have a confidence interval, and we're looking for a proportion. So this is going to be a 1 proportion z interval. So let's look at some conditions here. Let's zoom in, actually. Alright. So we want to do a 1 proportion z interval. Our conditions, we've got, okay, so let's check the model. So random, less than 10%, and NP, NQ, greater than 10. Alright, so random. We are told that it is a random sample. %. So we have 80 customers. That means if we have who ask for a water cup. If there are more than 800 customers, then this is less than 10%. Reading ahead, we suppose in June there are 3,000, but we can just write that condition down as well. If 800 plus customers, who ask for water. And NP/NQ is greater than 10. This is our successes and our failures. We had 23 and 57 are both greater than 10. So we had 23 successes, that's what it tells us, and that means we had 57 failures. Yeah. Alright, so we're going to do a 1 proportion z interval. Our mechanics, we'll write 1 pop z interval. We're just going to do this on the calculator. So, let's go and do a test. We got 1 proportion z test. No, we want an interval. There we go. 1 proportion z interval. Enter your x and n. 23 successes, 80 trials, and 95% confidence. Calculate. And write everything down here that we didn't already know. So we've got a p hat of 0.2875, and the interval is 0.1882 to 0.38668. So that is our interval. The only thing left is our conclusion. We are 95% confident that the percentage of customers who ask for a water cup and then go on to fill it with soda, the percent of customers who ask for water but fill with soda is between we're doing percent, so 18.832% and 38.668%. I don't like that but in there. I want to replace with who then go on to, because otherwise it kind of sounds like this is the percent of overall customers that ask for water and fill it with soda. Who ask for water and then go on to. Yeah, whatever. B. The manager estimates that each customer who asks for a water cup but fills it with a soft drink costs the restaurant 25 cents. Suppose in the months of June, 3,000 customers ask for a water cup when placing an order. Use the confidence interval in Part A to give an interval estimate for the cost to the restaurant for the month of June for customers who ask for a water cup but fill the cup up with a soft drink. Oh, well, I mean, that's the language they use, so maybe we were fine. Anyways, like, we have a percent, we'll multiply it by how many there are, and then by the cost, essentially. So, if we do 3,000 times 0.18832, this is the minimum number of people that we would expect. It's like 565. If we do 3,000 times 38668, that would be the maximum number of people, which is 1,160. Now, these aren't costs, these are people. So we're going to multiply these by the 25 cents per customer and get the min cost, 141.25 and 290. So in Part A to give an interval estimate, yeah, so between $141.25 and $290.